The presenter of today's webinar is Mr. Caner Taşkın. He is a PhD Associate Professor in Bosporus University. He is also Senior Vice President Technology of ICRON Technologies. His doctoral thesis is on the solutions for large-scale optimization problems at University of Florida, and he has won Pritzker Award from Institute of Industrial Engineering through this doctoral thesis. His research interests includes local area planning, scheduling, and optimization, and he has scientific publications in this area. Parallel to his academic studies, he has been working on commercial supply chain planning, scheduling, and optimization projects globally, in some companies like ASML, West Electronics, Trakia, Hayat Kimya, Smith, and Bridgestone. My name is Levent Özkan. I will be the host of this webinar today. I'm the director of Asia Pacific branch of ICRON Technologies, which is located in Singapore. Before going into the fun part, I just want to give some background information about our company. ICRON Technologies is an advanced planning, scheduling, and optimization solutions provider, and we have been doing this in the last 24 years. We have 70 plus customers around the world and 200 plus implementations in these customers. We have started in academia, so we have deep academic involvement, and we have ties with academia, and we have innovative culture thanks to this. ICRON Technologies is headquartered in Amsterdam, and there is a Asia Pacific office which is located in Singapore, and our R&D center is in Istanbul. Just before going into the presentation, let's talk about what we do and what's our passion. We provide integrated and intelligence platform for strategic, tactical, and operational planning layers. We cover all these layers. Although today in S&OP we will mostly focus on the tactical layer, we can also provide strategic and operational planning. Our aim is to improve the speed, flexibility, and the quality of decision making, because as we will explain briefly, decision making today, especially in S&OP process, is not fast, it's not flexible, and the quality of the work is not on par with the modern requirements. And we guarantee, by implementing an S&OP solution, return on investment through end-to-end supply chain visibility and also end-to-end supply chain optimization. I think there is a slight lag between the visuals and the voice, so I'm waiting for the screen to change for everyone. As in previous slides, we have talked about 70 plus logos we have under our belt. These are some of them. We have done many applications in this, and it's ranging from high-level sales and operations planning all the way down to the dispatching, advanced planning and scheduling. If you have any question about any companies or implementation in any companies here, you can email us or you can ask your question in the chat section. We can just cover that maybe in this presentation or later. Today we will mostly cover sales and operations planning, but ICRON platform solution is not only covering this area. Actually, there is a very unique proposition we have. We cover all the areas of planning and scheduling. So sales and operations planning, another popular area is advanced planning and scheduling, which does the detailed dispatching. We also can apply this solution to special production environments, for example, maintenance, repair, and overhaul, and also demand planning, capacity planning, workforce optimization, distribution planning, and inventory planning. From here, Mr. Taşkın will take and go through the presentation of sales and operations planning. Thank you very much again joining. I will leave the words to Mr. Taşkın.
Okay, thank you, Levent, and thank you everybody for being here. And I would like to welcome everybody and thank them for having spending an hour with us. And what I would like to do today is I have three sections in the presentation. In the first few slides, I will be recapping the S&OP process and the S&OP concepts in the classical sense, and to give some background information and to make sure that everybody's on the same page. And then in the second phase, I will be introducing some more modern ideas regarding S&OP and optimization-based approaches to S&OP. And then at the end, I will be talking about some customer cases where we actually applied those optimization-based S&OP planning in ICRON. And I chose 3 examples, and from different sectors and different countries with different types of manufacturing needs and S&OP needs. And I've been personally involved in all of those projects. And if there are any questions about specifics of a project, I will be happy to address them in the Q&A session. Now, I would like to first start by why we do planning and how planning matters, why planning matters, basically. Now, the way I see this, there's a company, that's our company, basically, that we're trying to operate, and it never works by itself in isolation, so it's somewhere operating within a competitive environment. So regardless of the sector you are in, there's always some competition. And of course, there is a supply chain. So the idea is to somehow make sure that you do the right things compared to your competition, and you utilize your supply chain effectively to, at the end of the day, get profit. Of course, obtaining profit is not the only reason why companies operate, but I think we will agree that it's one of the main reasons for any company to exist. And what kind of competition areas there are? Well, of course, there are many, but more or less the most important ones that I see are regarding delivery reliability. So can you make sure that your customer gets the right quantity at the right time and at the right location? So if you have higher delivery reliability, then that's a competitive advantage compared to perhaps some of your competitors. And quality is, of course, another competitive advantage. There are different aspects of quality, like adherence to standards, durability of the good itself, the service itself, the brand quality, R&D quality, etc. And there's, of course, flexibility that you need to also operate on. So it could be the flexibility in terms of the product itself, or the ordering process itself. So you could have allow more flexibility towards your customers, or you could have more flexibility in your internal processes so that you can actually create some competitive advantage. And of course, price is also a part of the competition. Now, if you notice, by good planning, you can actually improve a number of these. Delivery reliability should be clear, I think, from a planning point of view. If you can plan your capacity, and if you can plan your supply chain correctly, and if you can commit to the right customers, right due dates, then you can keep your promises, which would increase your delivery reliability. Quality is perhaps not as directly related with planning given the others, but there are certain manufacturing processes that requires a certain level of control. And if you make too many switches in the production environment, then the quality of the product actually deteriorates. So the idea is by better planning, you can have, at the end, have higher quality products delivered, manufactured and delivered to the customer. And flexibility is key because in many sectors there is some kind of flexibility. The flexibility could be either on the product specification itself, internal processes, and also internal materials used. So if you have alternative bill of materials, that's a flexibility. It makes things more difficult to plan and control, but it also gives a certain amount of flexibility, which the company can, through better planning, can actually utilize to lower costs and also have a positive impact on the price and therefore profits. So I believe that planning actually allows us to improve the company's competitive advantage if done correctly. Now, let's take a look at what the planning process looks like. And so this is like a time axis. Over the horizontal axis, you can see the time, and on the vertical axis there is now. So to the left of now it's past, and anything that has happened in the past is now experience. So it doesn't have much to do with planning. So if something has already started and finished in the past, then it has become a statistic, and it's not directly relevant with planning itself. Of course, planning is in regard to the future. So there's a real life that's coming up, and in the real life we have our expectations or our certain forecasts about the real life, or there are certain scenarios. So I could have high demand, I could face low demand, maybe some of my capacity will be higher than the current version, or it could get lower. So there is a number of scenarios that we are envisioning in the real life, and there's a number of possible decisions that we can actually make. And which decisions do we make and how we make is directly related with the lead time of the decision. So for any decision, if the arrows over here, the left-hand side of the arrow, left tip of the arrow represents the action and the time the action was taken. And once you initiate a decision, it takes a certain amount of time, which we call the lead time, until you see the expected impact. So for some decisions, it could be the case that you have made the decision earlier in the past, but you haven't seen the expected impact yet. So those are your commitments, and those are things like open purchase orders or open production orders. So something that you have committed to, but you haven't realized yet. So those are the things that you have to take into account in the planning or in the projection of the future. And of course, there are certain in planning, there are also some decisions that you expect to make later on. And in the future, I will be making this decision and I will see the output in 3 weeks. So those are some decisions that we project that will be made later in the future. And there are also certain decisions that you have to make now and execute now so that you can see the expected impact before it's too late. So those are the most relevant type of decisions that are made in the planning process, and because other decisions that you're projecting that you will be making in the future, they can be revised. But the decisions that need to be done now, it's very difficult to revise them, and even if you revise them, it might be too late. So the main part of planning is making the right projections for the future, considering all the commitments that are open at the moment, and also all the experience you gained through statistics from the past, and being able to analyze a number of different scenarios regarding the future and calculating the right projections so that you can actually get better and better decisions made. Now, let's talk a little bit about what a good type of planning environment should provide. Now, a good plan must be agile, and if there's something that changes in the real world, and which everything changes, some changes more frequently, some things change less frequently, but the real world is all about change. So when there's something that's changing in the real world, your plan should be rapidly modified. So that's what I believe a good planning must be agile. And preparedness is also an important key. So we need to be able to investigate a large number of possible scenarios before they really happen in the real world, so that we are prepared. So the more scenarios you can actually investigate before they happen, the more prepared you can be. And of course, flexibility is key. As I mentioned earlier, there is a number of different flexibilities regarding the product, regarding components that are used to product, regarding the manufacturing processes. So there is a lot of flexibilities, and if we can actually consider them in a right way, then we can actually utilize our resources and our flexibility better to provide better profits. And another key point in good planning is, of course, coordination between both different parties, different decision makers within the company, but also the coordination between alignment between the real state of the world, so what's actually going on, the observed state, so what our data tells us that's going on, and what the decisions we make. So the longer lead times between the real estate changing, our observation, therefore our data changing, and the decision that we're making, the longer the lead time of this, the worse for the overall outcome. So we want to eliminate as many lead times as possible in the observation of the real estate and also the planning process itself. Now, with this background, let's focus a little bit more on S&OP. Why S&OP? Now, in many manufacturing type of companies, there is usually a number of departments that actually have different roles depending on how close they are to the customer. And at the end of the day, if this is our company, in the middle, on the one side there are customers, and on the other side there's the suppliers. And in many industries, the companies are operated as in different functions, business functions. There's the customer-facing part, so usually marketing, sales, and that customer-facing departments are in that regard. And there's production department, and there's also a supplier-facing part where they deal with the interaction between the company itself and its suppliers. And of course, there's finance, which oversees the entire system from a financial point of view. And normally, there are different planning processes that we identify associated with each of these functions. So there's demand planning, there's sales planning, there's delivery planning. Regarding production, the goal of the production is to utilize capacity correctly. And then in the supplier side, there's material requirement planning, there's purchasing requirements, identification, and then shipment of the inbound materials. Those are all different processes that are associated with individual functions. Now, if you think about this, maybe there are too many boxes and there are too many functions over here. Of course, it's good from a concentration and focus point of view. It's good that there are different decision makers who are focusing on different types of problems. But in practice, what ends up happening is to ensure that these different decision makers and these different business functions can work in a distributed sense. So to make sure that they are not completely dependent on each other, we put a lot of inventory in between. So we put a lot of inventory of finished products so that we can decompose the decisions made by the customer-facing side and the production planning side. So that if there's something wrong in the production, it doesn't directly impact our customers. And same thing between suppliers and production. So if you put a lot of inventory in the purchasing side, then the production, anything that's going wrong in the supplier side won't directly impact the production. So that's putting inventory is one way of adding some amount of robustness into the system. Also, it's allowing different functions to work sort of independently from each other. But of course, inventory is very costly. And the idea in S&OP, the goal in S&OP is to actually look at individual functions and look at them as a whole, take their individual concerns, but also allow synchronization among them without hopefully putting a lot of inventory in the system and limiting flexibility. Now, I would like to talk at this point a little bit about the S&OP process in the classical sense. So there are different definitions of S&OP, and more or less they are along the same lines. And S&OP can be defined as an integrated business process through which the executive team continually achieves focus, alignment, and synchronization among all functions of the organization at tactical levels. So the key points here is integrated, first of all. So it's not S&OP is not a business process for one department only, but its aim is to allow integration of multiple business processes and business functions. And the owner of the S&OP process is the executive team, and we are talking about the tactical and almost strategic. So somewhere in between tactical and strategic level. And the whole point is to ensure that all business functions are aligned and they are synchronized. So that's more or less in different places you will see similar definitions about S&OP and what the S&OP is about. The way I see this is in many S&OP points, S&OP meetings, there are two main questions that are asked. How are we doing? So what's the current status? So how, let's take a look at our data and see from each different functions point of view what are the issues and what's the overall situation. So how are we doing as a whole company? And the other thing is, of course, there are certain projections regarding the future, certain scenarios. So what can we do to make things better in each of those scenarios? So these are pretty much how S&OP process and its content can be summarized from my point of view. And in the classical sense, the S&OP process is somewhere on top of the other tactical levels processes. It's closer to the strategic level, somewhere in between strategic and tactical. And this should be familiar to many of the viewers. And in the classical planning functionality, there are different stages like resource planning, demand planning, sales and operations planning, master production scheduling, MRP, and then detailed capacity planning, material capacity plans, shop floor execution, supplier management, etc. Of course, depending on the company and the sector, there are different planning functions also. Some of those may be used, some of them may not be used. There could be some differences, but more or less this is how the general planning paradigm looks like in the classical sense. And here I would like to make a remark that in one of the reasons why we have so many different planning processes is, of course, again, it has good reasons from a business point of view. So there are different people who need to work on those, and they need to focus on individual of those problems. But of course, there's also the technology and history behind this. So if you remember, one of the first algorithms regarding planning in the ERPs and also in the planning world was MRP. And the MRP algorithm and its first implementations are at least 40, 50 years old now. And that was pretty much the level of complexity that could be handled by the technology that was available 40, 50 years ago. So MRP, which is a very simple algorithm by itself, so MRP became prevalent, and then over time, rough cut capacity planning and master production scheduling, resource planning, demand management, etc., those kind of additional planning processes, as technology became available to make them work, they became different modules on ERPs, and over time we get so many different modules and so many different planning processes. So that's something that I will come back to later on, but I would like to already make a remark here. Now, again, in the classical S&OP process, there is typically it's suggested that the S&OP process should be a monthly process. So at the end of the month, there needs to be data gathering regarding the supply and demand. In the first week, there's demand planning. The second week, it's about supply planning. In the third week, it's pre-S&OP meeting. And in the last week, there's the executive meeting that takes place and the decisions are made. Again, depending on the context, you can see different variations of this, but in many sources, you will see a variant of this process, the classical sense. So in this, it's like a hierarchical process in the classical sense. So first, you do the demand planning and then do the supply planning, and then see the mismatches and to make corrections, and then do the executive meeting. So, but in many classical processes, demand planning is the leading factor in S&OP. Now, does it always have to be? Can it always be? Of course, this also needs to be thought per sector and per company, its needs. So it doesn't always have to be like this. It doesn't always have to be a monthly process, and could be parts of it could be integrated and modified depending on the company. But whatever you do, if you want to do S&OP, then there are different things that you need to think about. One of them is, if you want to integrate a number of those functions, you need to design a process of having multiple functions and multiple decision makers align together in this in the company, in the S&OP process. There's of course the human factor. So who are the decision makers? Who enters data? When is the data entered? Who makes the analysis? Who makes the overall decisions, etc. So the human factor is always important, and information is key. So what kind of information is available, and at what level of detail is that information needed? What's the timing of the information? So that's all something that needs to be figured out. And of course, the underlying technology. Do you just make the whole S&OP process? Do you make it run on Excel? Do you use a specialized software? So how does the technology, how do you support this from a technology point of view, including where the data is, in what kind of database or the ERP systems, what kind of meetings take place over what time intervals, and what kind of software and analysis you perform. So in any S&OP process, to design an S&OP process means that all these questions have to be answered, and in my experience, there is not a generic way of answering all of those, and depending on the company's needs and depending on what's the driving factor in the S&OP process, what's the lead times in the associated decision-making processes and data collection processes, depending on the lead times, the process itself can be changed. It could be a monthly process, it could be a bi-weekly process, it could even be a weekly process. So depending on needs of the company, these processes need to be designed, basically. Now, with this background information, after this background information in S&OP, I would like to actually look at more modern approaches to S&OP based on optimization. Now, for those of you who have background in optimization and operations research, may already feel that the idea in S&OP is to look at individual functions, take their concerns, also align their concerns with the management concerns, and look at the big picture and make a decision as a whole that's best for everybody. So that's already something like an optimization problem. Now the idea is instead of looking at individual business processes one by one and individual functions making individual decisions, the idea is to look at a number of things together, expand the feature of the decisions to be made, and not make them independently, but consider them all at once. Whatever is relevant for that S&OP process, it could be maybe material requirements, and the availability of materials is key, then that also needs to be part of the S&OP process. And if the resource planning, if the availability of resources or certain characteristics of resources is key, then that also needs to be part of the S&OP process. And as an optimization problem, in any optimization problem, we are talking about three basic concepts, and one of them is called decision variables. And the decision variables are the things that we want to determine. So how much inventory do I carry for a particular item, and how many productions, how much production should I be making, how many acquisitions should I be acquiring, and how much of the existing capacity should I be allocating to one customer versus the other customer. So all the things that need to be decided, we represent them as decision variables. And then there are certain constraints that need to be tackled. Some of them are technological constraints, and these are the things that we are not allowed to change, basically. So they come either from laws of physics, or they come from certain processes. In process industries, there's a number of resources that cannot be stopped. So even if you don't have any demand, maybe you cannot stop that resource, so you have to keep producing. That's a technological constraint. So it has nothing to do with the demand structure, but you have to actually make a plan that fully utilizes that particular resource. Therefore, that's a technological constraint. And of course, there are what we call managerial constraints. And the managerial constraints are regarding things that we don't want to change, or we prefer not to change. So these are things like budget, or certain targets, goals of the senior management. So I want to make a certain presence in a certain market very crucial. So the demand in that particular market must be satisfied, even if it's too costly. So that's a managerial constraint. It could be modified if needed, but we really don't want to change it. So that's the kind of things, those kind of managerial constraints also become constraints in the optimization problem. And at the end of the day, what are we trying to achieve? So what are our goals? So those are KPIs. Could be profit, could be minimizing cost, could be maximizing market penetration. So whatever the cost of the company or the goal of the company, their KPIs are, they become the objective functions of the optimization problem. So after designing the decision variables and the constraints and the objective functions, the problem becomes a mathematical problem. And and there are certain algorithms, very quite efficient algorithms for solving those mathematical problems. And at the after the solution of the optimization model, we get optimal values for those decision variables, which satisfy those constraints, and also which optimize the goals that were presented. So that's how we convert the problem from a business problem to a mathematical problem, and then find the best solution in the mathematical domain, and then reflect it back to the business domain. So that's something that's a general approach in operations research, and it provides a natural fit for dealing with S&OP type of problems. Now, of course, there are certain difficulties in this exercise. Part of it is in regard to the data. So the data may not be available. So maybe you could have sequence span setup structures in the actual production, but the exact data may not be available in the ERP environment. Or even if the data is available, it may not be completely correct or accurate. A typical example I've seen over time is expected arrival of purchase orders. So in many companies, when a purchase order is first opened, it's correct from a timing and quantity point of view. But as time progresses, quantity-based changes are reflected back to the ERP system, but timing-based changes are not typically reflected back to the ERP system. So even if the data is available, it's not completely correct. And timeliness of the data is also an important key, since there are multiple functions that need to provide data. Identification of a time where all the data has been entered and it's accurate can be an issue. And solution time and modeling complexity are also certain difficulties if you are dealing with a really large optimization problem. However, there have been certain changes or certain developments, technological improvements in the last decade, let's say. And two main factors are in regard to the information technologies and the optimization technology itself. So from an information technology point of view, we have much better hardware, like processor, amount of memory, etc. And the cost of those hardware has decreased substantially over time, and its availability has become wider and wider available. So we have better processors, a lot more memory that we can actually tackle more difficult problems with. And simultaneously, there have been very significant changes in the optimization technology. We have faster and more capable solvers, and academic research as well as practical experience of dealing with optimization problems and applying them in the practice has improved significantly. So we can actually find optimal solutions faster for larger problems. As needed, we can apply problem-specific heuristics for the problem. Since we can deal with more variables and more constraints, we can build more realistic models. And now we can actually perform integrated planning that looks at a number of concerns of different functions together, and plans an integrated generates an integrated plan that takes everybody's concerns into account and looks at the overall benefit of the company as the objective. On top of this, not only can we solve a single problem itself, a single scenario, but now we can do a scenario management. So we can actually create multiple scenarios, arbitrary ad hoc scenarios. So what if this happened? What if I had more capacity? What if I had less capacity? What if my shipment gets delayed? Anything that could be relevant at the S&OP level can be made into a scenario, and then we can create scenarios, we can compare scenarios, we can copy existing scenarios, we can merge different scenarios, so on and so forth. So technology has improved substantially to make this applicable in the real world. Now, ICRON is a software that has been designed to make this happen. So ICRON has been designed to ensure that large-scale optimization and planning problems can be handled efficiently and in a flexible manner. And the main flexibilities, main keys here are any decision support system must have three levels, basically. On one of them, there's data. And since a number of business functions contribute to the S&OP, the data is not typically available in just one environment. Data is typically spread over a number of environments. Could be part of the data could be on ERP, part of the data could be on some other database or Excel files, etc. And in the underlying problem-solving engine is also designed to be flexible. So there is a generic data model. ICRON enables rapid what-if scenarios, and also multiple users can collaborate and perform joint decision-making. And KPI management is, and optimization are also parts of the system. And there's also the user interface, since there is a number of different users with their own requirements. We need different user interfaces for managers and for planners and for other users. Now, at this point, I would like to discuss three cases that we implemented S&OP systems, optimization-based S&OP systems. They are from different sectors. And the first one that I would like to talk about is Trakyacam. Trakyacam is in the glass industry, flat glass sector. It's part of the Şecam Group with 2.2+ billion revenue last year. And it's second largest in Europe and fifth worldwide in the current numbers. They have operations in a number of countries and multiple facilities in each company. And the environment requires high manufacturing and logistic costs, and that's due to the product itself. That's due to the nature of the product itself. And on the demand side, there is uncertainty, and there's demand that's coming from other group companies and other external companies. And there is concerns like operational stock, safety stock, etc. But the real challenge comes from the product itself, product and the process, manufacturing process itself. And the product itself, especially color change between different products, requires a high setup cost. Therefore, a lot of products are manufactured in campaigns. So we can only manufacture certain products, group them together, and then produce them for 1 month, and then switch to another set of products and go back to the first one only in next year, something like that. So campaign-based production is prevalent in this industry. And there are complex co-production relationships between different products. So you cannot plan products individually, but if you are planning to product A, then you need to also take into account that with A, you have to produce also a certain amount of product B and also a certain amount of product C. And in the case of the glass, these proportions are not also fixed. So there are certain boundaries. You can adjust the proportions of the products to be manufactured. So by considering this in alignment with the demand, the forecasted demand, you can actually align sales and operations together. And of course, there are additional concerns like thickness changeovers. So the production process itself is discrete as a process, and discrete resources are used together. And one big challenge is that you cannot interrupt the production. Once you open up a production line, it needs to keep running for about 10 years continuously. and this provides a very little flexibility in the production capacity, in the adjustment of production capacity. Now, if you remember the classical S&OP, the classical S&OP starts with demand planning and then supply planning. But here, you have to take into account the characteristics of the production environment itself to make a good demand plan. So these two cannot be really separated, but you need to consider them together. And that's what we did basically. So we created an optimization model that handles those specific concerns, and we enhanced it with ad hoc scenario analysis. We did an implementation of this system in ICRON, and to enable the global S&OP process. It's integrated with a number of products of SAP. So they've been using SAP ERP, SAP BPC, and SAP BW, containing different data components. So we built a multi-entity, multi-user system that enables the global S&OP process for Trackejam. And it's been live for about 2 years now. And another company is at ASML. ASML is a manufacturer of lithography machines. So those machines are used to produce computer chips, computer tablets, cell phone, etc. All kinds of electronic equipments are used on ASML machines. And it's the high-tech industry. They have very expensive products and components. Their revenue is 6.3 billion in 2015. And they have a literally global supply chain. So the main production happens in the Netherlands, but there are also facilities in United States and Taiwan, and there's a number of suppliers worldwide, and it's literally a global supply chain. And the planning horizon is over 90 weeks. That's roughly 1.5 to 2 years region. And the reason is because they have very long lead times in material purchasing and also the production process itself. And so the product itself allows a number of configurations, and there are different options in the product itself. And the part of the challenge comes from the fact that it's the high-tech industry. Therefore, also all the components are also evolving continuously. So since you need to plan for about almost 2 years ahead of time, there will be a number of engineering changes in the product itself and its components, and you need to actually account for those engineering changes to make an accurate plan at the S&OP level. And there's a number of capacity-related concerns, supplier capacity, supplier changeover, and also specialized equipment for testing. Those capacities of those also need to be put in place. And something that's not very common in other industries is since ASML requires very high workforce skill, and since the workforce itself for doing certain critical things like software development, testing, configuration of the machines, since the workforce itself is limited, you need to actually plan around the availability of the, considering the availability of the workforce. So in the Christmas time, for about 2 weeks, almost the capacity is almost zero. So most of the production facilities shut off in the Netherlands plants, and then anything that overlaps with that time, you need to plan for the extended lead time. Also for the summer holidays. So over the summer holidays, roughly 20% of the capacity of the workforce is lost due to holidays. So you need to also plan for that accordingly. And then, so these are the things that you need to also put into account while designing the S&OP process and also analyzing the S&OP system. And what we did at ASML is we also built an optimization model that tackles those individual concerns of the system and provides integration with SAP, HANA, and there's collaborative planning, also multi-entity, multi-user support, since there are so many different planners. And we also enabled a global pegging, which allows traceability and visibility across the supply chain. So from any requirement, any demand, the users can backtrace into all the levels of the bill of material and all the shipments between different facilities, all the way down to purchase materials. So that allows global visibility of and root cause analysis of any delays and problems in the system itself. And the last example that I chose for today is Vestel Electronics. And Vestel Electronics is a large TV and consumer electronics manufacturer, and they're within top 3 in Europe. And they have a supply chain challenge. The basic reason is they have most of their customers are in European region, so almost 90% of the demand is to customers in Europe, and most of the purchasing is from the Far East. So their lead time in the purchasing is about 90 days, that's the average, and their lead time in the customer side is about 30 days. And so there's a mismatch between inbound supply lead time and outbound supply lead time. And they have a large number of models, several hundred customers, over 20,000 components, over 350 international suppliers, and it's a large supply chain problem. And one difficulty or one unique characteristic is they have different sales companies that are able to provide forecasts at different levels. So for the domestic market, the sales companies can provide forecast at the SKU level, but for international sales, that's not possible. So they can only provide a forecast at the high levels, which needs to be broken down into SKU levels dynamically, basically. And the product evolution is very rapid. So roughly every 6 months, the entire production portfolio changes. And as TV consumers, you probably have a feeling about how fast the TV evolves. We went really rapidly from LCD to LED to OLED to smart TVs, ultra high definition TVs, so on and so forth. So it's changing very rapidly. And the challenge here is to make an S&OP plan. You need to, especially for the next 6 months or so, you need to take into account that there's a number of products that are not even in the market yet, but you already need to start planning for. So you need to plan for items that do not yet exist. So that's one challenge at Vestel. And the difficulty between aligning the long purchasing lead times with short order processing lead times is one key. And one interesting part is the purchasing capacity is limited, since Vestel is already a big player, and since the supply of certain critical components is limited, you need to think about, you need to analyze how many of those materials you can procure, so that you can plan how many TVs you can produce, so that you can plan how many items you can sell. So it's not classical in the sense that you first plan the demand and then plan the MPS, run MRP, and then get the purchasing requirements. Since the purchasing requirements, the purchasing capacity is limited, you have to think into account the purchasing capacity together with the demand planning. So that's one challenge that's also appearing in other industries. And just to give you an idea about the scenario analysis capability and optimization capability system that we built for Vestel, we have some screenshots. So this system has been live for over 5 years now, and so this is ICRON and how the S&OP planning system for Vestel looks like to the end user. And in the process-wise, the way the system is used is at the end of the planning cycle, there is new forecast received from sales and marketing, and the S&OP planners use the planning module to analyze this forecast, basically. And the forecast can be at different levels, and it needs to be checked for consistency and also enable different scenarios. So what if we had more forecast was increased? What if it was decreased? How does it align with our capacity, etc.? So the way this works is on ICRON, we built a Excel pivot-like structure, which allows filtering and grouping by arbitrary attribute values. and forecasts and other constraints can be defined for any of those arbitrary values. And in the background, there's an optimization model, and any change that the user makes manually on this screen is automatically reflected back to the optimization model. And next time somebody runs optimization, it doesn't start from scratch, but it uses warm start capability. So within seconds, the user can actually modify something and then run optimization and get a new result within seconds. And so the S&OP planners work on a number of such scenarios. And then during the S&OP meeting, everybody looks at the same KPIs and looks at the same data. So how much forecast do we have? How many customer orders have we received? What's the availability of our critical components? So that's the aggregate view, and also a breakdown to details is also presented to the same user. So the information is the same to everybody, and the number of ad hoc scenarios can be executed during the S&OP meeting itself. And so after the S&OP meeting, once the consensus plan is reached, it's actually released to across the facility, across the company. So other departments can log on using the web module to see the part of their plan, and they can also compare different plans, and not only in the current planning session, but they can also compare with earlier plans. So this is the release plan from last month, and this is the release plan from the month before, and these are two scenarios for my current plan. So how do they all compare? So this can be also done across the web, so that everybody reads the same information of the consensus plan and acts accordingly. So this is how the plan is generated and released. But of course, the real life also continues in the meantime. So as the time progresses, even though we have released a consensus plan, there are new customer orders that are being realized, and there are changes in scheduled receipts, so which may actually cause infeasibilities in the plan that were made. So the system continuously in the what we call the execution module, the system continuously looks for those infeasibilities, and if it detects an infeasibility, then it can actually identify, alert the user, the planner, and in an intuitive setting. So basically it tells these are the forecasts that you had entered, and these are the existing customer orders, and this is the existing capacity, and these are the scheduled receipts, and it's not possible to satisfy all the forecasts with the existing capacity or the existing scheduled receipts. So there's also a continuous tracking of netting between forecast and the customer orders and the rest. And as a result of this project, we identified a number of gains, and basically the most relevant ones could be the planning time. So before this, the planning was done on Excels manually by S&OP experts. It was taking them a lot of time to collect the data and then process the data and come up with one scenario. It was taking them more than 2 days to analyze one scenario. And after the system went live, now they can work on, well, they can generate an S&OP plan in about 3 hours. And most of this time is actually spent on analyzing alternative scenarios. So data load and then optimization and analyzing a number of scenarios. The whole thing takes about 3 hours. And the infeasibility checks, they were done manually, now there's automated. As a result of this, the S&OP meeting frequency went from monthly to weekly or any time as needed. Since the sector is very dynamic, the more frequent those decisions are aligned, for the better for the organization, and the senior management solved this and redesigned the S&OP process from a monthly process to a weekly process. And the planning accuracy has improved, and inventory levels as a result of this project have decreased by about 5%. So the financial benefits are estimated to be over $1 million for the first year, and I'd like to remind you that this has been live for more than 5 years now. Now, In the remaining few minutes, I would like to, before the Q&A, I would like to just summarize brief points and then enter the Q&A session. And the main points that I tried to make today is S&OP is a critical business process, and the main main idea is to ensure cross-functional alignment, and it requires availability of situational awareness, basically. So in what situation are we right now, and visibility. So what's causing us problems, what are the root causes, and it requires rapid scenario analysis and coordination between business functions. And the optimization technology provides a practical and flexible technique to support S&OP process, and ICRON as a tool enables optimization and scenario-based S&OP process, and it has done in a number of companies across the globe so far. So that's all I have. So if there are any questions, I would be happy to address them. Thank you.
Thank you very much, Caner. We actually have a question from Mr. Rowe. How quickly can ICRON S&OP provide first results after the implementation?
So to give you an idea, in the Vestel case, the initiation of the project began early in 2011 in January, sorry, and it went live in 6 months, and it has been used ever since. So it started providing benefits 6 months after the initiation of the project, and it has been already in the first year. It created a value of over $1 million. So that's a pretty quick turnaround.